Hello, everyone. Good morning, or good afternoon. It's 12 p.m. Eastern Time. Welcome to the Data Engineering Process Fundamentals session on Introduction to Data Lakes and Data Warehouse. You are welcome to make any questions during this session. Just go ahead and hit the chat. I'll try to keep up with the questions and I'll try to answer some of them uh, as um, as time becomes available. This should be an interactive session, so feel free to ask questions. Also, feel free to follow that link on GitHub. That will give you a lot of the material that we are using for today. So welcome, everyone. Very nice to have you here. Today, I have a question for you. And really the question is about, have you been to the lake near the warehouse? If you have not, today is the day. Today we talk about data lakes, data warehouse, and how they benefit your data engineering process, your data engineering, your data pipelines, and everything hosted on the cloud. My name is Oscar Garcia. I'm a data engineer, cloud engineer. I focus a lot on doing data solutions, app solutions, everything running on cloud infrastructure. Let's start the process. So before we get into data lakes and data warehouse, we have to be aware of one thing, which is data engineering. What is data engineering, right? So it's really just a process that we need to establish to follow a series of steps that can enable us to organize ourselves so we can actually build a solution. Okay. A lot of the steps involve, discovery process, planning, orchestration, building a data warehouse, and building some of the process with the data analysis. Let me know if you guys can hear me properly, just to make sure sound is on, everything should be okay. So in today's focus of our data engineering process, we look at certain topics, which is data lakes and data warehouses, and how do we use them? How do we go about to do a discovery process, a data analysis? And like very important as well is the concepts of design and infrastructure planning, right? So as we go through this process, we have to be able to build infrastructure associated with this resources. So that is a very important step. And then we go and cover a little bit about data lake and pipeline and orchestration. This is actually the code execution and the data pipelines to get the data from a particular source into our data lake. We then move on to data warehouses and talk about the design and implementation phases of the data warehouse, how we can go about to do this within our data engineering process. Finally, we look at analyzing and visualizing the information that comes from our data warehouse. So as I said before, you have a link to a GitHub. It is right there on the chat. It's also on the first slide. So please go ahead. You can load that, follow along with us with the presentation, or you can review it later on. There is a lot of information there, so we won't be able to cover a lot of the details. But I do want to give you some of the key areas where we can actually introduce you to some of the concepts and the project, and then you can follow afterwards. First, let's talk about what is operational data, right? So operational data is the data that most of you are probably familiar with this, right? You build an application, you build a website, and that application and websites, they talk to a database, whether it's a SQL Server or Oracle database, or whether it's a NoSQL database like Cosmos DB or Firebase. So this data is actually mostly used for small transactions, right? So it's used by the applications. It's not meant for a lot of heavy data streams or or batch transactions, right? So the features are that it supports small transactions. If it is a SQL database, it has a relational data structure or a document JSON structure for NoSQL databases. And it's really you can use it with small queries for data analysis, but not for heavy data analysis, right? So it's really not best to use for reporting system, for large queries, and not it is not meant to be used for centralized big data system, right? And I'm sure a lot of you have been to the case where you actually maybe you have a SQL server and you're running heavy reports on it and you have data contention, right? And applications are suffering for it. Queries are timing out and things of that nature, right? So, and the reason behind it is because those databases are not meant to support that kind of system. But the question is, so what is? What do we have to use? What do we use for to support such systems? This is where we introduce the data lake. And what is a data lake, right? So data lake, you can think of it as an analytical data staging. So after you have the operational data, that data has to go somewhere. And the purpose of going somewhere is for the analytical purpose, where you actually can do your heavy reporting, your data analysis, your data visualization, and so on. So there's a staging area for which often is called a data lake. And it's really an optimized storage system for big data scenarios. Its really purpose is to store raw data in its raw format without any transformation. So basically the goal is that your data sources like operational data and some CSV files you collect from some other systems, what have you, you will store that on the data lake, right? So its features are really to store the data in raw format. It could be structured data like CSV or unstructured data like XML documents, or even Parquet files, right? Parquet files are a column-based data structure that is compressed and it's a little more, it performs better to read it, right? So you can store these files on the data lake. So they're there for staging purposes. One of the advantages of this is that it's very low cost, right? So if you think about databases like perhaps Oracle, SQL Server, data storage is expensive, right? And the queries of data, when you query the database and what have you, is expensive, especially in a cloud scenario. So data lake is very low cost for that purpose. But it's really not designed for querying or data analysis, right? I just said something about querying the data. It's really not designed for that purpose. You could query it, but you can query it without really much optimization, right? So, and I'll show you really how it could be used. And it could be used for external tables by most systems. So a lot of systems actually enable you to say, I want an external data source, and you can link the server, you can link the data storage, and you can bring up and load certain sources as external tables. The data lake enables you to do that. And it enables you to do that in a way that you can actually give it a folder or you can give it a file pattern, right? And if it has a CSV like structure or a Parquet structure, then it's able to render that as an external table where you can query it. But of course, it's not optimized for that. It's just really to sort of do analysis, sort of like read the data, but not to actually use it for the analysis for analysis purposes. So then what do we do for that, right? What is the next step? We know this is like a staging area and we have massive data. What do we do next? This is where the data warehouse comes, right? So now the data warehouse is really now it's a centralized storage system to store all the data that's integrated from multiple sources, right? This system is indeed designed for big data scenarios with low operational costs, the transaction databases, but it's actually more expensive than a data lake because for its billing purposes, it's about storage and about bandwidth usage, right? So as you query data and the data is coming through the pipeline, then they calculate a cost associated with that data stream. And this is really the system that is optimized, that is fast, is powerful enough to host the information for analytical purposes, right? So you can actually now do data mining, you can do visualizations, you can do analysis, you can use any kind of tool you want to be able to query this and query lots of data and not have the problems of data contention, data blocking, and all those issues. So its main goal is really to store historical data in relational tables with an optimized schema. So what that means is really that as we build a data warehouse in what we call the design purpose of the data warehouse, we actually need to think about what is the schema. Is it a star schema, right? And that's really just the design of a relational structure where we actually have foreign keys and things of that nature. Yes, this goes more towards the power using SQL to be able to do that. And data warehouses are designed to support that, but at a large scale. It can integrate with external resources like I talked about. So it is a very beautiful way to be able to say, let me tap into my data lake, bring this data and do data processing, right? So there is a staging process where you process the data, break it down so you can move foreign key relationships into different tables. And you could do that with SQL, right? So there's options of doing it with SQL, or there's options to doing it through code with some other layer, like maybe like a Apache Spark or some kind of data pipeline that's running outside with Python or C# tool you are using. But this is really now, so is designed, this system is designed for big data scenarios where we can actually hook our dashboards into it and be able to look at the data. And there is, of course, there's way that we can actually offload some of the data that's no longer valid into data lakes, with the purpose of a lot of these systems. What it would do is, let's say your data governance policy is 5 years retention period, then it can offload some of the data that is 5 years old into a data lake, right? Which then it saves you on costs, on the cost of the storage. But in the cases where there is some kind of request to be able to bring data that's older years, this kind of systems are designed to be able to look at that source as an external table, bring it on a temporary basis, so analysts can look at it, can do data analysis, and they can decide how to use that information and then offload it later on. Okay, but now that we have our data lake, we have our data warehouse, we have everything. How do we go about to use it, right? What's the whole purpose of it, especially for the data engineering process, right? So that is really where the process kicks in, right? And be able to understand how do we gonna leverage this data lake and this data warehouse, we need to understand the data. So we need to actually understanding our operational information or the external system we need to integrate with. We need to experiment and do data analysis. So we need to download a sample file to see how this is going to work, understand how this data is available, if it is available through data streams, which is real-time integrations, whether it's a batch process, maybe the data is available every 2 hours or every 2 days, and so on. So we have to figure all these requirements or all these specifications and work it that way. But the important point here is that data analysis is needed. And we can use tools like we can use SQL, we can use Python, we can use Jupyter notebooks. If you guys are not familiar with it, definitely there's some resources on the GitHub repo where I use a lot of Jupyter notebooks to do some of this analysis, and we'll look at a little bit of that later. But just understand that these are all these tools are available for us to do this. And basically we can make we can come up with requirements and specifications about how we're going to consume this data, because this is actually creating that blueprint to be able to say, this is how we're going to get this data. This is, we're going to now have to consume it, get it, and put it into a data lake, and from the data lake process it and integrate it into our data warehouse. So data analysis is key in this process. And of course, now that we we understand that we require a data lake and a data warehouse to be able to do this process, we need to understand design and planning. And the design phase of this is where we actually now lay out the foundation for the system, right? So this is where we actually think about system architecture, right? How are we going to build this data pipelines? How are we going to use this data lake and this data warehouse? So this is very key for this process, right? So usually for this kind of process, we use tools like GitHub for the repo and for CI/CD actions, which is really just pipelines when you commit changes to code, and it just automatically builds it and deploys it somewhere. Because our approach here is not to do anything manual, but our approach here is to kind of automate everything. So our data pipeline is more a what we call cloud native type process or project, right? So we talk about GitHub CI/CD. When it comes to building the data lake, data warehouse resources, we need the VMs that we need for the programs to run. We need to think about Terraform to build out an infrastructure, right? And if you're not familiar with Terraform, it's really just a way, it's just really a sort of a system where you define these files, and these files will tell you based on the provided cloud how to build a VM, how to build a data lake, and so on, right? So, and that's an easy way to kind of recreate environments or add new environments to your farm when needed. And definitely we need to isolate where we run our code. So we need to use Docker containers to manage these dependencies, so we don't have this big issue of deploying somewhere where something is not compatible with what we had, the way we wrote our code. So Docker containers and Docker Hub, which is really a container repo to be able to remotely say, download this Docker image, which has my code, deploy it, and kind of run it. So those are very important aspects. And I cover more of that in the GitHub repo. And once we build this data lake and data warehouse infrastructure that is ready to go for us, now we need to start thinking about how do we build this data pipeline, right? How do we orchestrate this information, right? So, and what is a data pipeline, by the way? If I'm sure you are familiar with this concept, but it's really just a workflow task that can be executed, right, in Docker containers, or it can be executed by some turnkey solution by, for example, Azure Data Factory. But the idea here is that to support this, the operations of the data pipeline and orchestration, we need to provision our VMs and data lake and monitor those cloud resources, right? So this is where, after the design, this is very important. Now we know our VMs. Now we know our data lake. Now we know our security requirements to be able to integrate the systems together. So what's important here is to start thinking about how are we building this data pipeline and how we are orchestrating its process. And by orchestration, we really should be thinking about how do we do deployments? How do we monitor the health of the pipeline? How do we orchestrate and schedule its runtimes? So we're able to automate the process, right? And so that is very important. So whether you do it through code or you do it through a turnkey solution, it's important that those aspects are provided by the solution you're picking up, right? So now we have the data pipeline and orchestration, and the idea of that was that gets the data from an external system into our staging data lake. But now that data is in raw format, right? It's really hard to use if it's a CSV file. We need to kind of structure that a little bit more. That's when we start thinking, okay, let's use the data warehouse, right? And the data warehouse is really could be, to simplify, we could divide it into design and implementation phases, right? The design phase is really now, as I said before, we need to talk about the schema model. What does the database system looks like? What technology stack is required to support the implementation and operations of this? What this means really is that we need to start picking up what is the data warehouse solution that we're using, what kind of system is it, what is our schema design, whether it is a star schema, which is a foreign key relationships with fact tables and dimension tables, and what kind of code do we use Python for this, and do other containers and run them in VMs, or do we use the power of a data warehouse engine and we use SQL Server to do the transformation, the mapping of all this data, right? So those are points that we definitely need to think about, and we cover this on the GitHub repo as well. So. And once we define what that design looks like, now we go into the implementation phase of this. And this is really where we start building the concrete structures, like the dimension tables and the fact tables, and do the data transformation, which will include data mapping, transforming, perhaps casting the data types, changing the column names, right? So it becomes more of it follows our schema model, right? And the whole idea of this is that this is not a manual process, right? We don't want to be doing this manually now, doing SQL statements to alter a table or add a new table or add new records. We want to automate this process. So we want to build a framework that enables us to do this automatically, right? So we need to create different models. For example, if we need to keep updating our fact tables and dimension tables, we need to create an incremental strategy, which basically appends new deltas into the tables. So we keep our data, our system with the latest information that's available. And of course, now that the data warehouse is available, once we get the data into the data warehouse, our dimension tables are available, our fact table is available. Is when the analysis, the true analysis of the data starts, right? Because now the data warehouse should have gigs of data, perhaps, right? Depending on your data load. Gigs of data with all this information. This is now the time where we can actually explore this again to really understand what the data is telling us. So now being able to go and say, what are those dimensions and measures from the fact tables telling me, right? Do I have outliers? Do I have trends? What are my distributions? For example, in this sample data set that we have, this is we're trying to analyze the arrivals and departures from subway stations in New York. So we can basically try to, maybe areas of interest will be distribution by station, distributions by perhaps a particular day and time frame, right? Are we busier in the mornings, afternoons, what have you? So, and the end goal will be that information, so for a purpose, right? And the purpose could be some kind of maybe marketing, targeting consumers, right? For some reason in a geolocation. And I talk about geolocation and those things in the GitHub repo as well. But definitely, so once we have that, now we can accomplish these activities by using same thing, Python. We can use Visual Studio Code. We can use Jupyter notebooks. And we can do our analysis on notebooks and just do queries, analyze them, do charts, and be able to kind of get an idea of what is it we're looking at. Because this works as a sort of a discovery for the data analysis for our final end product. Because and our final end product will be a visualization platform, right? So this phase here is really this fits mostly into the hands of data engineers and data analysts that are working on small teams to be able to understand what this data looks like, right? But it doesn't work for the purpose of the enterprise, right? It's not working for the entire enterprise to be able to look at a high level what is the data telling us and how we can use it. So for that purpose, that's when we have to build a visualization platform, right? And there are tools us to build this kind of platforms, right? And these tools they connect directly to a data warehouse. And what you could do here also, there's a lot of engineers that would rather, instead of using like Python, they would rather just come into these tools and start doing their data models, right? So they create their data models based on how they want to do it, and then they read from the tables, they add their filters, and then they're able to create their pie charts and their bar charts and things like that of what they want to do, right? So, and the idea is that this is a very enterprise level quality dashboards that can be shared to the enterprise, so people can actually look at it and target the areas that they want. So, for example, maybe your interest is a particular station, and because that station is near a particular area that you want to geofence or that you want to market to, and then you want to look at the analysis of the data by departures and arrivals, right? So you have tools like Power BI, you have Looker, Tableau. There are other tools out there that you can use, and some of these tools are very powerful and enable you to do this kind of analysis. So that's basically what we will have for the presentation. Now we're going to jump into looking at the repo. You can take a screenshot of this. It really just gives you the technologies we have used. It gives you the GitHub link again. It gives you also my blog with some of I wrote a lot of I wrote a series on data engineering process, and you can follow that series. It talks about all these different areas. But let's jump into the GitHub. Take a look. So I'll talk about Terraform a little bit, and I'll show you that immediately. Think, and you look at it more when we go into cloud infrastructure, but Terraform really what it is indeed is an automation tool to be able to say, if you ever worked in the cloud, you can actually say, for example, I want a data lake, or I want a VM, or I want some resource, right? Terraform is a tool that by defining a script, you can say, build me this resource in this cloud subscription within this workspace, and put this security configuration to it. So you can configure that, and then that script, once you run it against the Terraform engine, it actually translates that script into a bunch of cloud commands to be able to start building our resources. And you'll see more of that in detail. Okay, so let's jump really quick. First, discovery. So if you take a look at this, first of all, this goes into the entire data engineering process, right? Where we have a problem statement, and this is a real use case, right? We have a problem statement. What are we trying to address? How are we going to address it? It goes into the analytical approach, data set criteria. It talks about what the data looks like, what we need to do, what are the requirements, right? And it gives you architecture on how we're going to build this, how we're going to use the data lake, the data warehouse, and the process that we are using to be able to build this. So you can take more time and look at this. But the end product really would be this dashboard. And the whole idea of this dashboard is really to enable us to look at the data, enable us to be able to say, hey, this is the data based on my and all the stations based on this day and time, and you can see the distribution. So you can see this is a very powerful enterprise level tool. And the tool that I use for this is called Looker, right? It's just like Power BI, just like Tableau. It's a very powerful tool where you can actually create components, you can create filters, and you can actually do your database visualization projects with this, right? So that's the end product. And the idea is, if you read the end goal, the problem statement is to kind of be able to define geolocation boundaries based on the station. So this enables people to kind of look at that data and be able to say, hey, I want to target these people near this station because they're near my business, and that's my people, the people that I want to target. But to do that, right, and like I said before, we go into the discovery process. And the discovery process is that we know of a system that has data, and we need to query that data and make observations of that data, right? So you have Python scripts here, you have Jupyter notebooks files there that you can use, and I'll show you some of that. But the idea is that you go through all these observations, and you can look at this. Just a quick question: you guys are able to see my screen, right, with the GitHub repo? Let me know. It should be, right? So yes, it should be. I see. Thank you. Okay, and you go through the process. You build your data dictionary. You query the data, and you start making observations and conclusions, right? And those conclusions could be, like in this case, I don't like the day and time field separated like that. Maybe I need to create a new column called created, right? I need to identify a station. This is a CSV file, so maybe I need to create the station dimension table, the what do you call it? The booth dimension table, right? And then you start thinking along the lines of creating requirements to be able to build your fact tables and how to analyze the data. So it's important for you to kind of look at all this and observe how this is done, and look at the Jupyter notebook. If you look at the discovery file, Jupyter notebook, really what it is a interactive file where you can actually put, you can add snippets of code, and you can run them, right? You can run them on the file, and then you can see the output, right? So in this case, we're saying take a look at this file. I want to print the first 10 rows and see what the data looks like, right? And then we can start experimenting. We can start saying, hey, how would I go? And if I merge a day and time field, what does that look like, right? And you start going through that process. Experimenting, you start adding your observations, right? Okay, so I will need to cast this entries and exits are integers because those are my units, those are my measures, right? So entries and exits, what that really means is entries really means people are entering the subway station. So it's actually a more of a departure. They're coming into the subway station to depart somewhere. And exits means people are coming out of the subway station. They go in through these gates and they're exiting. So and this is important because what happens is you can measure the traffic of people for that station, which gives you a geolocation, and you can understand around you can understand the times, even the days, right? Days and daytime, where this is more where there's more traffic of people, right? So you work out the discovery that way, right? So now we did that discovery, so now we need to move on into infrastructure, right? And this is where the Terraform questions are coming in, right? So hey, I need to build a data pipeline. What do I need to do? So this is design and planning. How do I do my data orchestration? How do I do my deployments? So this is where we start thinking about continuous integration, continuous deployment, containers, Terraform for cloud infrastructure. So this is going back to the guys that people asking about Terraform. Is what they call infrastructure as code, which enables us to manage resources across multiple cloud providers. So it's really in an automation process to be able to say deploy or update or delete, right? You can deploy, you can update, you can delete, and you can manage resources, because in a real enterprise, you build not just one resource, right? You can probably build different environments. You can do development, QA, staging, production, and then that continues to change based on requirements. So it's important to have a continuous integration, continuous deployment or delivery process for infrastructure. This is only infrastructure, has nothing to do with the code. Okay, so it's just building resources. That's all it is. Okay, so a lot of people get that confused thinking, oh, it's the same as that's where my code goes. No, the code will go on a CI/CD as well, but this one here is just deploying the resources that we need for our data pipeline, right? So you can go and start thinking about terraforming here, where you can actually go and tell Terraform, build me a VM, a cloud storage, a data warehouse, and you can have that file and run it against multiple environments to kind of clone the same environment over and over. So this just goes through all the information how do you run it, and these are the steps for Terraform, right? Where you actually go to initialize the Terraform environment, and you can actually give it a subscription ID or a project ID, where you actually target that cloud infrastructure, right? Because it needs to have security to be able to have access, right, and deploy the resources, right? And you can apply changes. You can review changes by doing plan. It will tell you what it is that it's trying to build, and you can do destroy, which is it will just basically destroy it, right? And this is the cycle, right? You code the file, you plan it, you review it, and then you apply it. And the files of interest here is really the Terraform folder, where you can actually have the variables in the main. And the variables really is just a bunch of declarations that says, I want to build these resources, right? I want to use this region. I want to use this storage class. I want to use this data set. With data sets like a database for BigQuery, right? By the way, we're using GCP, Google Cloud, for this presentation. And the Terraform main file really is just saying, okay, this is my file definitions. I want to create this could be Azure, right? It could be AWS. The whole idea is that this is agnostic to the provider, to the cloud provider. And then you define what are my buckets that I need to build. That's the data lake, right? Blob storage. What kind of BigQuery data set, which is the database, in the VM instance. And these are very simple files. There's a lot more to it. If you had a VP, if you had a private and subnet resources, it will be a lot bigger because it will give you a breakdown of a private network, a private resource, subnets, and so on and so on. So that gets more complicated. That's more networking. Okay. But then we have, after running this, executing these commands, we ready when it comes to orchestration of the process, right? So we have the design, we have the planning, everything. So for data orchestration now, this is really now our pipeline. We're actually coding it, or we may be using something like a data factory. Whichever way it is, the point here is that we need to be able to say that we're going to run this piece of code, we're going to integrate these files into our data lake, we're gonna and we want to monitor. So we want to track it, we want to schedule it, and we want to be able to get some kind of notifications in case there are failures. Okay. So for example, if you can go here all code, or you can go with a turnkey solution. So let's say if you go all code, let's say Python, then you need things like Apache Airflow, you need things like Prefect Cloud, you need things like, you know, Apache Spark to be able to do kind of orchestration tools to be able to build some of this stuff, right? So for example, in this case, we use Prefect Cloud, and what it is really just a library that provides all this code for us to be able to, as we built our data pipeline, to be able to use decorators, function decorators, to be able to say this is a pipeline, and I want to track all my activities. I want to log all the data that I'm doing, right? So you can read all this. It just gives you all the details on how this works and how we track the flow, how this orchestrates, how do we schedule it, right? But the files here that are of interest to you are the flows and the deployments, right? And also blocks. Blocks is really we create components, right? So we think about this as a pipeline, and we need components. And some of the components could be the security access to a data lake, the security access to some cloud infrastructure, right? And then we build components that are reusable across multiple data pipelines. And deployments is really that unit of work that we say, look, we're going to build this on a Docker container and we need to deploy it, right? And we deploy it on through a GitHub CI/CD or through a Docker hub, right? So it really depends on how the approach of your infrastructure. But those tools exist. That's the important part. Understanding that these tools exist and are available. But what you want to take a look at here is that you want to look at the ETL Web2 GCS, right? So this is Python code. If you're not familiar with it, it's pretty simple. It's really not that complex. But the idea is that, you know, you grab, let me go ahead and make sure that you guys can see this. I hope that's good enough, that you can actually see the parameters that are passing, and then you actually create what's called a main flow. And this main flow, what that does, it actually enables us now to say, we decorate it and say, this is part of this, right? And by doing this function decoration, right, or attribute, we actually can log it, right? So there is telemetry being logged into the systems for us to be able to track it. And that's really the important part of this, okay, to be able to do that. All right, so okay, so so then you can, let me just go back here. Quick deployment just to see. So if we were to deploy this on a Docker container, you will see that the main entry point is established here. So you will see how in this process where we build a container, we're actually telling it to use main flow as the entry point, right? So that's really how this works. So now we're going to put all this code into the container and we're going to run it. So how do we do that? How do we put all this code in the container? Basically, we do that by using our Docker files, right? So if you look at Docker files here, we tell it, right? We give it a command and say, hey, I want to use this Python image. I want to copy all these Docker requirements and all of my application requirements and copy all of my code into this containers. And what it does when we build this Docker container, it just puts all the Python code with all the dependencies into that container, right? So that's really how that that will work. And then we have a container that we can use. We can run it in an isolated environment anywhere. So now our orchestration works. We got Prefect doing the logging, and you can see that in a little bit more detail. But what's important here is now moving on into the data warehouse. And for the data warehouse, quickly, it's the same kind of process. We can go with a tool, or we can go all code. Since we already use Prefect Cloud for the pipeline into the data lake, now we're going to use a system called dbt, which is another Python library that enables us to grab the data from the data lake, transform the data, and put it into data warehouse with different with incremental strategies and validation of the code and data. Or the data and data transformation and all those things. The difference here is that instead of just creating applications running on a VM, the dbt just really executes a command that goes into the data warehouse, and the data warehouse executes a bunch of SQL queries to be able to run all this. So all of this runs into the data warehouse. And the way that magic is being done, you can read all this. It shows you how to run this, how to build this, how to build the ERD for our data warehouse, right? But the way the area of deep interest here is dbt, right? And what happens here when we build the models, right? You will see that we have staging models and we have core models. And what that really does is that staging models just really, it creates a view, right? And it just have this particular sort of a script to enable to tell you what the columns should be and things like that. But this is like creating a model, right? It's creating a model, and basically what it will do is when you start defining your core models, now it starts getting into more of a SQL structure, right? So you can see that this is an incremental data structure. What that's saying is build out the script with this rule, which is, hey, eventually I'll have more deltas, more data coming in. So I want to be able to increment the data. Even though it doesn't look like it like this, it's hard to see. You only see like a SQL. There is a process that what it will do is will create temporary tables. It will create the deltas into that table. It will create all the, depending on, this is really like the dimensions for a station. It could be the fact table as well, all those things. So it will handle all that through SQL. It will just all of it be through SQL. So if you take a look at this one, right, the same things, an incremental table, and now we optimize it too. We can create clusters, right? So we can create clusters, we create index, right? And this is key for the optimization and the cost optimization of our data warehouse. So this just creates eventually, once you look at this folder here, in the dbt folder, there will be something called, let's see, you can have models, you can have, let's see, where is this? The SQL statements, and okay, no, because it's not uploaded. So what will happen is there will be a build folder in there, which what that does, it gives you the actual SQL output of this. So what it will do is it looks at that SQL and it deploys it into the data warehouse, right? When it comes to data analysis, the same process. This is where we actually go and start doing a final analysis, right? This is where we actually look our data from either the data warehouse that you export a CSV, or you query it directly, and you start building out your dashboards, right? So you could build a concentric Python dashboard, which only works for small teams, or you can just build, and this is a concentric, right? This is using Python. But you could also build a low-code analysis tool like Looker and all that, and actually build this enterprise-level data warehouse visualization projects. And you can look at analysis IPYB, the notebook there for doing some of that. And you can look at Looker, the dashboard, for actually seeing how you can interact with a filter based on distribution, based on stations and things of that nature. But that's basically basically the end of this presentation, guys. There are a lot of materials here. That's why the GitHub repo is there, to be able to just get some of the concepts, kind of get introduced to some of those ideas, be able to share with you that information. So you can actually go ahead and read it on your time and be able to take a look at that and enjoy it. But so just a quick question, if you have time. So Airflow is more for that data pipeline process, right? So we separated that. So what do you use for deployment? So yeah, so deployments, really you could use them with when you build your containers, you can upload your containers to GitHub, to Docker Hub, and that's just a repo. So if you look at the code, what it will do is it will download that image, and it will just install it basically, right? So you download that image, and once that image is downloaded to your VM, you run that image like if it was an application, right? So you will just run it that way. So or you can basically deploy it through, for example, GitHub. Let's say GitHub has your code. You can just go and through the build tools of GitHub, you can actually build on the fly. You can build a container image right off the bat, and without pushing it to the GitHub to Docker Hub, you can just push it directly into that VM. So for example, your CI/CD pipeline into GitHub will have to have access to your Google Cloud or Azure Cloud environments to be able to push that image. I mean, and that's a secure way. That's the best way to do it with containers. If you want to be able to just do the code push, for example, plain Python files, you could do that too. But then the risk is that you have to make sure that those VMs are well maintained and there are no compatibility issues with the code. There are tons of tools that are specific for building pipelines, and those are more like turnkey solution tools. I don't really advocate for any of them. There's so many of them. I can't really tell you. Most of the tools that we do is really through code. We don't really go a lot with some of these tools. I can't really, but there are tons. I can't really tell you that I have an expertise on a turnkey solution for GCP. But basically anything that's Spark related, they will use for that. So Apache Spark, and which I use a lot, is a data pipeline, data transformation tool that you can actually, from it, you can create Python scripts. You can call APIs to get that data, download the data into a data lake, transform it, do the mapping, and put it into into your data warehouse. It will do the whole pipeline for you. But you have to add components to track the telemetry, right? So as you do this pipeline, you need to log all the steps to be able, because the whole thing is orchestration, right? Be able to track it, be able to understand that that's not failing somewhere or something is happening. So you're gonna have to add that too, okay? So a lot of this GCP, Azure Cloud, what they do is they really create products on top of that type tool, like Databricks, for example. Databricks goes across all the clouds, right? Azure, Google, AWS, and all it is underneath is Apache Spark. That's all it is. So you just got to become familiar with that and see what's the turnkey solution that you use. Fast API, I'm not familiar with Fast API, not sure how it works, so I can tell you. Yes, actually, we are actually having a recording live on YouTube. Once that recording is done, I'll send guys an email through the group, so you guys actually see it on YouTube. Please give it a like, and go to my GitHub repo. Please give it a like, support it, so I can continue to grow it. If you notice, there's something on the cooks right now, which is the data streaming, right? And data streaming now talks about Spark and Kafka. Right, this is really, Spark is that tool that I just talked about, Databricks uses and all those things. And this talks about now data streaming. How do we get that data in real time, and how to get it into dashboards in real time, as opposed to a batch process. But guys, thank you very much for being here. I really appreciate your time. I'm really glad to share this with you. And please give me a follow, and we'll be in touch. Thank you, guys.